pole. Suppose this is pole A, pole 1, this is pole 2, and this is pole 3. Okay. Now, you know that there are some disks which are kept in this pole, and we need to shift that disk from one pole to other pole, right? And there are certain first diskette, this is second diskette, and this is the third one. The diskette which is at base is larger as compared to its consecutive one. So it goes in this smaller. Now, what we want to do, we want to move the diskette from this pole 1 to this pole 3, suppose, for example. What I will do, there are two rules. What is the rule first? That only one at what you cannot at a time put a larger disk on a smaller one. You cannot put a on smaller one, right? That means it should not happen like this. The smaller is there and greater is larger is above that. This cannot be done. Okay. So this thing we need to solve, right? So what we will do? First, we will move this small diskette to next pole. Suppose this small diskette I have moved to pole 3, right? The small diskette I have moved to pole 3, right? One at a time. Then what I will do next? I will move this 2 to diskette number 2 to pole 2, right? You can see here diskette 2 to pole 2. Now this is the larger one, this is the middle one, and this is the smaller one. Now can I transfer disk 1 to disk 2 above disk 2 from pole 3 to pole 2? Yes.
Yes, sir.
Yeah. So you can see here that I have moved the diskette from pole 3 to pole 2. And now what can I do? Now I can move this 3 to pole 3, right? Now I can move this 3 to pole 3. Okay. So this I have done here. So in this way, what we are doing, we are moving the larger here. Now, what is our target? Once again, now this has been moved. Now we won't move this diskette, right? We won't move this diskette because it has reached to its final destination. Now what we will do next step, this one we will move here, right? One we will move here, and then two we will move here, right? Two we will move here. This is two, and then this one we will move over here, right? So in this way, we can transfer the diskette from one pole to other pole with the limitations, right? Any doubt in this? But now these were only three, so it was very easy for me to illustrate you the demonstration. But in some cases, it may happen that there may be number of diskette may be very high. That is, say 5, 6, 7, 8, 9, 10. So in that case, what we will require, that large number of steps we will require, right? So we will just take poles, one poles. So right, here we are having, say, this is first diskette, this is second diskette, third diskette, this is, there are four diskettes. So 1, 2, 3, 4. Now for solving any problem, right? It's a case of logic development. Whenever we want to solve any problem or we want to find the logic for any task, we need to think of an intermediate case. We need to think of intermediate case. Along with that, we also need to think boundary conditions. We need to think boundary conditions, right? So these both things we need to consider. But in this case, we have to think about intermediate case. Now you will tell me that why you are not thinking of boundary conditions here and why you are thinking of intermediate case. It's because of experience only. We can start with either we can start with boundary conditions or we can start with intermediate case. But Considering my example, I am starting with intermediate case. Now, this is 1, 2, 3, 4. Assume that you have moved disk 2, 3, and 4 here. What I am assuming, intermediate case, that I have moved this upper 3 diskette here, right? And then what will remain? We need to move the 1 to final. So I will move then 1 here. Okay. That means after this, what will happen? You will have this 2, 3, 4 here, and you will have 1 here, right? Now what will be our next task? This is our source and this was our destination, right? This was our source and this was our destination. Now the remaining task is what? To move this 3 diskette to here, destination, right? So this is source, this is destination, this is say temporary. This will become destination and this, right? So what I will do, I will move this to here and then move the third one to this destination, right? So this thing we have to continually do till all the diskettes are moved from source to destination. But so what will be our algorithm? Our algorithm will be what? First, move n minus 1, because see here there are 4 diskettes na? So I have to move this 3 diskettes only. Move n minus 1 disk to intermediate pole, right? To intermediate pole using, so suppose this is our source, this is our destination, so this will be our template. So move this from source to destination using these, right? And then the next step will be what? We have moved n minus 1 diskette, right? So move n minus 1 diskette source to temporary, right? Source to temporary using the temporary. We will move to intermediate, right? Temporary one. And then we will move the last disk, end disk to destination, right? Then we will move end disk to destination. And then once it comes here, the final, the first comes here. Now what is our task? 3 are remaining. So out of these 3, 2 we have to shift to temporary, right? So move n minus 1 diskette from temporary to source using D we can do, right? Means half, first n minus 1 will move here intermediately, then last diskette will move to destination, and then out of this 3, again 2 we will move to this pole, because now this pole has become empty, right? I will show you once again. What I have done, I have moved the last diskette here, and now 2, 3, 4 are here remaining diskette. So out of this 3 diskette, we have to move 2 diskette to here, right? And the last one to here. Okay, so it will become here. Now what will be the next position? Here you are having 2 diskette. This is blank, and this are having 2 diskette. This is 1, this is 2. So out of this 2, again 1 I will move here, and this remaining 3 I will move here, right? This was 1, 2, so 3 will come here. And then this 4 is remaining, so directly you can move this 4 to here. Okay. So in this way, we will call the same function for moving the diskette from one place to another place. Every time what is happening? Every time we are moving n minus 1 diskette, right? So value of n is gradually decreasing. Now how long this value should decrease? Till to 1, right? जब तक नहीं तब तक हम उसको मूव करेंगे. जैसे ही 0 हो जाएगा तब हम उसको क्लोज कर देंगे, राइट? So we will see the program for this, and then we will start with our next topic. Here, okay, tower of Anita. Tower of Anita. Okay, fine. So see, very first, what is the value of n we have considered here? The value of n considered is 3. And we will call this tower of any function by passing the value of this number of diskettes, and this is the pole number 1 from 1 to 2 using 3, right? So this is 1, this is 2, and this is 3. We will transfer from 1 with source to destination using the intermediate one, right? So this function will be invoked. Are you able to understand?
Yes, sir.
Hold. Yes, how many students have been 38? Okay, fine. So you are able to understand. So what will happen? This is the driver code. We are invoking the tower of Hanoi function first time here in the main program by passing the value 3 as a number of diskette, and then we are passing the source, the destination, and the intermediate, right? Why we are passing this source, intermediate? So just to know how the diskettes are being moved by this recursion. So this function is called, right? And we will repeat or recursion, we will do the recursion till the value of n is greater than equal to 1. That's all. So our first target is what? We need to move n minus 1 from source to destination. We need to move n minus 1 from source to destination, and then we will move the last one. What was our intermediate step? Move the diskette n, that is the from source to destination. So that we are moving by writing the command. Last diskette, right? We are writing, we are moving the n diskette by writing the move, by printing the diskette which we are moving from source to destination. And once we do that, then again we have to move n minus 1 from temporary to destination using source, right? So here what is happening? The source and destinations are changing after you move the top n minus 1 diskette from source to destination. So if you run this program, you will see that what we have done, we have moved diskette 1 from rod 1 to rod 2. I can show you here. Uh, just a minute. I have to open your diagram, right? Open. This. Okay. Now here, if you see, I have moved this one from rod 1 to rod 2. I will draw. I have to. How can I show you? So if I do this, this will vanish. Okay. So what I have done, I have moved the diskette 1, which is this here, the top diskette to pole 3. Okay, I will just change the number here in my program so that it will be aligned. We will write 3 here and 2 here so that you will be able to. Okay, fine. See now, 1, 2, 3. Here you can see that I have moved the diskette 1 to 3, right? The smaller one I have moved to 3. Then second diskette from 1 to 2. Now next, if you see, the second diskette was here. Now I have moved that second diskette to 2. Okay, and then I am moving disk 1 to pole 2. Disk 1 from 3 to 2. See, this disk 1 from 3 to 2 I am moving, and then I am moving rod 1 to 3. So next, that rod from pole 1 to 3 I am moving diskette 3, right? Now next what will happen? Move diskette 1 from rod 2 to rod 1. Diskette 1 from rod 2 to rod 1. So this diskette will be moved here. So I'm moving here. Okay. So I have moved this here. Then next step is what? Move 2 from 2 to 3. So now I am so I have moved diskette to 2 and then moved in from rod 1 to 3 and move this one from rod 1 to 3. So in this way, moving all the diskette from pole 1 to pole 3, right? So with the help of recursion, we are able to do all those things. So simply what you have to do, you have to, sorry, I have not used this function. I have called this function. Yeah. So any problem in this? Yes,
No, sir.
students.
No, sir.
Okay, fine. So what I will do now, we'll start with the next topic, that is trees. Okay. Now, what do you mean by tree? Uh, if you go through the real life example, right? If you go through the real life example, what do you mean by tree? Have you seen tree somewhere? I think you might have seen like this. This is the trunk, and then these are the branches, right? These are the branches, okay. And to the branches there are leaves, okay. I'm not good in drawing, but you can imagine, right? There are multiple leaves. Huh? I'm drawing only single leaf here. Assume these are the leaf, right? जैसे बचपन में निकाला होगा हमने ऐसा लीफ, राइट? ऐसा निकाला होगा ना लीफ, राइट? So this is and this part leaf. So this is trunk, that is you can call this as a root, and these are the branches, right? These are the branches, and these are the leaf. Okay. So, and if we see example of computer, what do you mean by tree? Then I will show you one example of tree. Here you see, just a minute. इधर दिख रहा है, एक मिनट. यहाँ पर बोलने को होना चाहिए, इसके नीचे आता है ना, एक मिनट, नाम तो बताना चाहता हूँ. या अभी देखो यहाँ पर मैंने क्लिक किया, राइट? तो ये आपका सबसे रूट हो गया. दिस इज आवर रूट, राइट? ये इसको रूट बोलेंगे हम, कंप्यूटर मैनेजमेंट. दिस इज रूट. व्हेन आई क्लिक ऑन दिस, राइट, you get 3 nodes, right? So these are nodes. Then if you click on this, you get another nodes. If you click on this, you get another node. If you click on this, you get another node. If you click on this, you get another node. And when you click on this, then there are no nodes. These are the leaves. So this is an example of tree, right? This is an example of tree, right? Suppose once again I will do. This is our root. When I click on this, I am getting 3 nodes here. 1, 2, 3. When I click on the first, I am getting number of nodes here. When I click on this, I am getting again number of nodes. Now when I click on this, now there are no nodes. So these are leaves, right, which are don't having any nodes. So this is the last node having leaf nodes only. No further extension of the tree. But here if you come, yes, like this you are having different. So this is last one. So this is an example of tree in our computer system, right? So in computer, I can say like this. Suppose this is my root. Okay, I am calling this as a root node. I think you know node. What do you node? What does node mean by? It is having minimum two fields. One field contains data and other field contains a pointer. Right? That is called as node in our case. So this is a root node. This root node may contain multiple nodes. I will take example of only two here. I will call this as a left node and will call this as a right node. For this left node again it may have two nodes. One is left, other is right. For right also you may have left and right. Now this may not have further nodes. इनको आगे नोड्स नहीं हो सकते. So these are called as लीफ नोड्स. इनको क्या बोलेंगे आखिरी वाले को जिसको कोई नहीं उसको बोलेंगे हम लोग लीफ नोड. And these nodes are called as intermediate node. इनको क्या बोलेंगे हम लोग intermediate. And the node which is at the top is called as root node, right? So there are three terms here. One is root node, other one is intermediate node, and the last one is leaf node, right? The leaf node doesn't have any more branches. They are the last node, and that's why they are called as leaf node. Okay. Any doubt here?
No, sir.
समझ में आया क्या आपको ट्री के बारे में? Okay. So these things are called as edges. ये जो link है ना, this link is called as edge. Link को edge बोलते हैं, right? इसको node बोलते हैं और आखिरी वाले को क्या बोलते हैं? Leaf बोलते हैं. So normally what trees we are going to study will be a binary tree. कौन सा ट्री पढ़ने वाले हम लोग? Binary tree. What do you mean by the word binary? That a tree, a node is having at the most two nodes. एक नोड को कितने नोड रहेंगे? दो नोड रहेंगे. उसको हम बोलते हैं binary tree. You may have tree like this also. You may have tree like this also having three nodes. This tree is not called as binary tree क्योंकि इसको तीन नोड है, right? So it is not called as binary node. Binary tree. The tree which is having at the most two nodes or any intermediate node or root node will be a part or will be classified as binary tree. अब जब हम binary tree की बात करेंगे तो we know that only every node will have two more nodes at the most, not more than. Okay. So suppose I am considering this. So this is having two nodes. If I consider this, this is also having two nodes. It may have one node also, right? Not necessarily always it will have two nodes. It will have 0, 1 or at the most two nodes. Suppose this is my node 1. Now my node 1 is what? It is a root node. This is say node 2. This is node 3. This is node 4. This is node 5. This is node 6. Node 7. And this is node 8. Now here, can you tell me which are the leaf nodes? Yes. Can anyone tell me which are the leaf nodes?
8, 5, 6, 7.
Yeah, 8, 5, 6 and 7. These are the leaf nodes. And intermediate nodes?
4, 2, 3.
Yeah, 4, 2 and 3. These are intermediate nodes, right? These are intermediate nodes because they are having some branches. Okay. But every node may contain data. It's not that If it is an intermediate node, it won't contain any data. It will contain data, no doubt. Along with data, it will have left link and right link. So whenever we talk about the node, any node, it will have a data, and it will have a left pointer, and it will have a right pointer. Minimum three fields will be there: data, left pointer, and right pointer. Suppose this is my node containing data 5, left pointer is none, and right pointer is none. Then what you will call this node as? इस नोड को क्या बोलेंगे हम?
Leaf node.
Yes, leaf node, because the left and right are none. That's why it is a leaf node. Yes, वही सवाल को अलग तरीके से पूछा मैंने केवल. Okay. So if you want to reach to node 8, suppose हमको we want to go from 1 to 8. How you will go to 1 to 8? आप कैसे जाएंगे 1 से 8 पे?
1, 2, 4, 8.
Yeah, you will go to first 1, then from 1 you will go to 2, then from 2 you will go to 4, and from 4 you will go to 8. So this 1 to 4 8 is called path. इसको क्या बोलेंगे हम लोग? Path बोलेंगे, right? Yes, these are the definitions which we have to keep in mind. That it is called as path. Means the link of nodes which are to be visited to reach the destination from the source. Our source क्या है आपका? 1. Destination क्या है? 8. So from 1 to 8, if you want to go, you have to visit 2 and 4 in between. So 1 to 4 8 is called as path. Now there are few more terminologies such as parent and child. Suppose this is your root node, and this is sibling 1 and sibling 2. So for this S1, who is the parent? R is the parent, right? So R is parent of S1 and S2, whereas S1 is child of R, right? Same is the case for S2. S2 is also child of R. So from this we can say that R is parent and S1 and S2 are child. Suppose if I am having one more node here, say S3, then what you would say? S1 is parent of S3, right? S1 is parent of S3, and S3 is child of S1. Now who is parent of R? Can anyone tell me? Parent of R कौन है? R means root. Suppose parent of root कोई है क्या? None.
None.
There is no parent of root because it is the first node of the tree. So that's why it won't have any parent. And who will be the child of leaf node? Leaf node को कोई child होगा क्या? Leaf node का child? No. So there will be no child to leaf node and there will be no parent to root node. ये दो चीजें ध्यान में रखना है. No parent for root node and no child for leaf node. ठीक है, ये चीजें ध्यान में रखना है. Okay. Then suppose now this suppose I am drawing one more here, say S4 S5. Now if I consider this as a whole, right, this I can call as a tree. Okay. But if I consider only these nodes, right, and if I draw it separately for just visualization purpose, S2, S4, S5, it is itself a tree. Can we call this as a tree? Yes. Because here in this tree, S2 is a root and S4 and S5 are children, right? But if it is a part of this entire tree, then it is called as subtree. इसको क्या बोलेंगे? Subtree. That means what we can say, a tree will have multiple subtrees, है ना? Multiple subtrees. The tree is composed of multiple subtrees. A subtree may also again compose of again a subtree. अगर यहाँ पर मैं ऐसा करता हूँ, वापस ऐसे लूप बनाता हूँ, suppose S6 and S7. So this will again become a subtree, right? That's why in general what we can say, a tree will have a subtree which also may consist of subtree, right? Any doubt? So what we have seen, a root node is there, intermediate nodes are there, leaf nodes are there, right? Leaf nodes are there. Then root node is not having any parent, leaves are not having any children, right? And intermediate nodes are having both parent as well as children. Tree consists of multiple subtrees. And then what do we mean by path? The nodes to be visited from source to destination, including both, is called as path. Right? Okay. Suppose I want to go from R to S7. Suppose I want to go from R to S7. This is my S7. इसको S7. इसका पाथ क्या होगा? R to S2, S2 to S4 and S4 to S7. So पाथ क्या होगा? R, S2, S4, S7. This will be the path. ठीक है? Now the next term, which is essential for the concept of the trees, are relatives, right? What I can say, suppose this is my tree, so I am giving name here T. T is having node, say X. X is having node, say B, and say G. P is having another node, say D. Sorry, C. C. C is having another node, say J, and R. R is having node, say K, and S. Now here, in this example, J, node J, node R, node K, and node M are the descendants of C. Are the descendants of C. That means what we can say, C is ancestor of JRKM, right? C is ancestor of JRKM. That means what we can say in general, T is ancestor of all nodes, right? Of all nodes. T क्या है? Ancestor है. And all remaining nodes except T are descendants of T, right? जैसे family tree बनती है ना, मान लो ये grandfather है, for example, he may have children 1, children 2, children 3. Children 1 may have 4 and 5, like this, 6 and 7, 8 and 9. So now, can you tell me the descendants of C2? Descendants of C2?
C6, C7.
C6, right? And suppose I am writing one more thing here. Now descendants of C1, descendants of C1,
4, 5, 8, 9, 10, 11.
right? So in this way, you will come to know about the descendants and ancestors, right? It is just like your real life example. Okay. Now we will start with the concept of binary tree. As you know that we will be considering only binary trees. We won't consider any tree having more than two nodes to its parent node. Means there will be only two children for any node. Right? That tree will only consider. Okay. So by default, what we will do, if this is my root node, to the left side, the node I will call as left node, and to the right side I will call as right node. So I will make change here. I will write T here, suppose T for tree. इसको नाम क्या दूंगा मैं T. So this is the root node in this case, and this is the left and right. So in this way only I will going to consider the tree having more maximum two nodes. Any, but it may have zero, it may have one node. In this left may have only one node, and this right may have two nodes, right? Even though it is like this, it will be called as binary. In that case, it may not be a complete binary tree, right? The tree may be like this also. Suppose this is T, this is having only right node, having only right node, having only right node. This may be also a scenario. You may have a scenario like this also. Suppose this is a tree, this is left, left, left. First condition scenario I am saying, talking about. Every node will have only one left node. In this case, every node will have only one right node. This is the case, right? So these are all the types of binary trees. Okay. Here, if it is like this, right, then this is called as a complete binary tree, because here every intermediate node is having two nodes. So that's why it may be called as complete binary tree. But this is also binary tree, but it is not complete, right? It's not a complete binary tree. Okay. This is also a binary tree, but it is not a complete binary tree. So we have to see these kind of trees, and then how we can make these trees a complete binary tree, right? That we will see. But before that, we will see some more definitions which are important. Those are called as say levels. Now, if this is the case, the root node, this T is what? Root node. It is having level 0. Always the root node will have level 0. The next node will have level 1. The next node will have level 2. The next node will have level 6. Right? So the level will go on increasing as it moves downwards. Right? The level of root node will always be 0, and then it will go on increasing from root to bottom. Right? That is what we call as level. Then if I just a minute. Hello.
Good morning, sir.
Good morning.
Sir, Srimas is calling you.
I am taking lecture actually. He is here.
Okay, fine.
He is here.
Yeah, actually, I'll tell her that.
So ask that I will come after 10 minutes. Huh? And my lecture is going on.
Okay, fine.
So I am
Okay,
coming
fine.
in
Okay,
10
fine.
minutes. Fine.
Thank you.
Okay. So where I was? Yeah, I was talking about levels. Right? So what is the level of root node? Can anyone tell me?
0.
0. Then if I ask about the size of the tree, the another terminology is size of the tree. The size of the tree means what? Total number of nodes in a tree. Total number of nodes in a tree. Right? That is what we mean by size of the tree. Now, what is the size of this tree? This one. कितना साइज है इसका?
8.
4 और 2 8 कैसे गया? 7 ना?
7, yes, sir. Yeah.
1 2 3 4 5 6 and 7. The size of this tree is 7. Right? Few more terms are there Say for example, height is also there, suppose, right? Now, height of the tree is what? The number of levels in the tree. How many levels are there? Accordingly, the height will be there. So the height of a binary tree is the number of levels in it. For example, suppose we are having this binary tree which we have considered here. Right? Okay. Now this is having level 0, this is having level 1, and this is having level 2. Right? So if this is the case, height will be what? Hmm? Height कितना होगा इसका?
3.
Yes, height will be 3. What will be the height of this? This one?
4.
4, right? So in this way you can find out the height of the tree. Okay. What is the width of this? Width of the tree? 1, 2, 3, 4. Right? 1, 2 is what? How many number of nodes are there in a parallel, horizontal? How many nodes are there? Here the number of nodes are 1, 2, 3, 4. So in this case, the width will be 4. Right? So accordingly, you can remember the definitions of these kind of terms. Right? So height is there, width is there. One more term is there that is called as depth. तो क्या बोलेंगे हम लोग? Depth. Now the depth of the node is its distance from the node. जैसे for example, ये ले लो आप, right? इसको मैं highlight कर रहा हूँ. What is the depth? Distance from this. How many node it is far? 2. So the depth is 2 here. इसका depth कितना हो गया? Means height up to that node. You can say depth is means what? Height up to that node. That is what we call as depth. So, size, height, depth, path, leaf node, intermediate node, parent, child. Okay, these are all the terms which we should know as far as trees are
Sir.
concerned. Yes.
So, sir, depth is only for the individual node, no? And height
Yeah.
is for the entire structure.
Yeah, height is for the node which is at that level. Node depth is for the node at that levels, and height is for the entire tree. Right? Height of the tree. You can't say depth of the tree. We will say depth of the node. Right? Height of the tree and depth of the node. मतलब इंटरमीडिएट नोड जो रहेंगे उनके लिए हम डेप्थ वर्ड यूज कर सकते हैं, और जो लीफ नोड रहेंगे उनके लिए हम हाइट वर्ड यूज कर सकते हैं. राइट? We can use height for a leaf node and depth for intermediate nodes. That we can use. Yeah. Any problem?
No, sir.
Okay. So now what I will do, I will finish here, or I will stop here, and from next lecture we will start the implementation of our trees. That how the trees are created, how to find out the height of the tree, how to find out the depth of the tree, how to find out the size of the tree. That all first we will see, that whatever terms we have seen, who is the parent, who is the child, right? Whatever terms we have seen today, that terms we will first implement and try to find out through Python program about all those. Required to do first, because once the tree is cut, then only we will be able to find out all the terms. What is the size? What is the node? Intermediate nodes created? What are the leaf nodes? And all those things we will be able to see that. Okay. So I will just take attendance first, and then I will stop. Today's date 1, 9. A division. 1, 2, 3, 8, 9, 10, 11. 1, 2, 3, 4, 9, 15, 16, 18, 20, 21, 22, 24, 25, 29, 30, 31, 33, 34, 37, 38, 40, 42, 43. 3 division. 1, 2, 3, 4, 5, 9, 10, 16, 17, 18, 19, 21. Okay, fine. So we will meet tomorrow and we will see first how to create the tree and then find out the values of all those terms. Okay, fine. Thank you.